Hello, dear students. Today we have Proposition 31 from Book 3. 31, Book 3. In a circle, the angle in the semicircle is equal to a right angle. The angle in a greater segment is less than a right angle. The angle in a less segment is greater than a right angle. Further, the angle of the greater segment is greater than a right angle, and the angle of the lesser segment is less than a right angle. We'll show you. Here's our circle. Here's two semicircles of that circle. Here's the greater segment, blue with the dash. Here's the lesser segment, the blue dash with the blue dash. Okay? So, hold that fixed. We're going to talk about this semicircle, we're going to talk about this greater segment, and we're going to talk about this lesser segment. And we're going to prove, it's required to show that the angle, look at this angle now, that angle is in this semicircle. Look, here's the semicircle, and you can do it here too. Anywhere, any angle that touches the points of the diameter would be an angle in the semicircle, obviously. So it could be anywhere. And then this angle is the angle in the greater segment of the circle, and this green angle, say, is in the lesser segment. We're going to prove that this angle is right, equal to a right angle, that this angle is less than a right angle, the one in the greater segment. Look at that. It's in this segment. And the one, see how it's in this segment? You put it anywhere along here, it would be an angle in this lesser segment. We're going to prove that that's always greater than a right angle. Further, we're going to show that the angle of the greater segment, and the angle of the segment always is by this, contained by the circumference and the chord. Okay, so we have this angle right here, this angle. I'm going to prove that that's always greater than a right angle, and the one in the lesser segment, the one of the lesser segment, this is going to be less than a right angle. Okay, pretty cool. Here we go. Let's connect some points here. I guess I'll do it with, I'm going to go get my markers. Back. Okay, let's start off by connecting some points here. What color do I want to use? I'll use black. Alright, let's get our center. We know we can find the center of a circle, that's no problem. That black's not going to work real well. This black. And then let's connect some points here. Okay? Now look at this triangle, and look at this triangle, okay? In this triangle, it's obviously an isosceles triangle because these two are radii of this circle. Radii of circles are equal. So this is equal to this. Okay. Likewise over here in this other triangle, this angle will be equal to this angle because these are radii of the circle. Look at this triangle. These two sides are equal because they're radii of the circle. And we know that, therefore it's isosceles, and isosceles triangles, the angles at the base are equal. Therefore, this is equal to this. Therefore, this plus this is equal to this plus this. Okay? So this whole angle is equal to these two angles. Great. I'm going to do a little trick here, say. I'm going to extend this red line. Great. Now, look at this triangle. This here is an exterior angle. Look, we continued the base. I didn't do that very well. That should be straight. Let's make that straight. Make it look nice. Okay, that's a little bit straighter. Okay, this angle here is exterior angle to this triangle. This triangle is base extended, therefore this is exterior angle. We have proven that the exterior angle is equal to the opposite interior angles. Therefore this angle is equal to this angle plus this angle. But this angle is also equal to this angle plus this angle. We showed that. Remember? Because this was equal to this and this was equal to this. Therefore, the whole is equal to the two parts, the two other angles. So this is equal to these two angles, and this angle is equal to these two angles. Therefore, this angle is equal to this angle. And we've shown in the past that if in a straight line, a line we set up on a straight line, and the two angles are equal to each other, those two adjacent angles are both right angles. Okay, so this and this are both right angles. Therefore, this is a right angle, obviously. And this is the angle in the semicircle. Look at this semicircle. This is the angle in the semicircle. Therefore, we've shown the first thing. The angle in the semicircle is equal to a right angle. Now, we know that because this, in this triangle, this is a right angle. We know that now, that this angle and this angle are going to be together equal a right angle, okay? So one of them is alone is clearly less than a right angle. So this is clearly less than a right angle. Got that? Right angle triangle. The other two are equal to a right angle then, because the interior angles of a triangle equal two right angles. So this plus this equals one right angle. Okay? Therefore, one of them is clearly less than a right angle. So this angle is less than a right angle. But this angle is the angle in the greater segment. You see this greater segment? And this is an angle in that greater segment. It can show the same thing wherever we put that angle. Therefore, the angle in the greater segment is less than a right angle. Now look at, got that? Look at this quadrilateral. Blue line, red line. Quadrilateral. We've shown in the past, and in a circle, I'm going to do that a little bit differently. We've shown in the past that in a circle, opposite angles of a quadrilateral are equal to two right angles. So this angle plus this angle plus this angle are equal to two right angles. But this one's less than a right angle. So this one must be greater than a right angle if the two together are equal to two right angles. Get it? This plus this, two right angles. This less than a right angle, this is necessarily greater than a right angle. But look at this angle. It is the angle in the lesser segment. See this lesser segment? Remember, semicircle, greater segment, lesser segment. We've shown then that the angle in the greater segment is greater than a right angle, right? So, angle of the semicircle, right angle. Angle in a segment greater than a semicircle, less than a right angle. Angle in the segment less than a semicircle, greater than a right angle. Now we need to show the second part of the prop, that the angle of the greater segment is greater than a right angle, and the angle of the lesser segment, the angle of the lesser segment, is less than a right angle. How do we know that? Look at this angle, and look at this. This is clearly a part of this, right? If the part is equal to a right angle, the whole must be greater than a right angle. Okay, therefore the angle of the greater segment is greater than a right angle. Same thing over here. Look at this angle. This angle here is a part of this angle here. And this angle here is equal to a right angle. Therefore, one of its parts is clearly less than a right angle. Correct? Because the whole is greater than the part. Great. Therefore, we have shown that in a circle, the angle in the semicircle is a right angle. The angle in the greater segment is less than a right angle. The angle in the lesser segment is greater than a right angle. And the angle of the greater segment is greater than a right angle. And the angle of the lesser segment is less than a right angle. Quod erat demonstrandum. Thank you very much. Bye-bye.